In part 3 now, we are going to use the mesh we generated in stage 2 and set up a model in Pixus. So we generated this mesh called Southwest real, which was refined according to depth. So let's go back to Pixus. I've already opened Pixus just to save time. We've got 4 models, Pool Harbour model, and 3 conceptual models of the Solent. So click on Workflows, add New Workflow, and again we will set up a 2D Telemach model, but this time we will use the real grid that we've just created. So let's call that let's rename and call that real Solent. So the first stage is to select our cellophane file, add cellophane layer. It's in day 3, so let's go to day 3. All files, we should see our Southwest real there. Open it up, go for points. Again, let's use the projection that we used earlier. So UTM WGS 1984, and for the zone we use 30 north. UTM zone 30 north. Apply, apply. And here is our mesh. So what we're going to do is zoom in, and let's make sure you start on the west boundary. Select the point there. Zoom out. Zoom in on the right boundary. I'm just going to do that again because I think I've selected 2 points by accident. Make sure we just select 1 point. I keep saying selected 2, so I'm going to zoom right in. Zoom to the other side. Select that from there. Edit boundary. Let's try that again. Let's select that as our first point. There we go, 1 point selected. We like to select another point on the other side. Zoom right in. Select that. Add boundary. Okay, we are going to use imposed elevation. Okay. If we go back to the mesh nodes and look at, you can see we've generated. Now, it's really important that you do it in order. So first the west, then the east. If you did it the other way around, then obviously you're forcing in the boundary file, you'd have to do it the other way around. Okay, we've got a Southwest 3. We go into day 3 again. Forcing, again we can look this up in a editor. Here we've actually now got 11 points. So we've got water level at 11 points. So what we need to do is, along that boundary, we're actually going to drive it with 11 points. So let's select the file. This will take a couple of minutes to do. This will be sea level 1. And the normalized length is 0. Add a second one. This will be sea level 2. Now because there's 11, we want to go along 0.1, which is the equivalent of 10%. And you'll see that by the time we've added in our points, we should be up to 11. So let's do this. What I'll do is just add in 11 points straight away. Come back and fill in the details. We want them to be interpolated each time. So we want 11 points in total. Only the first one is uniform, all the other ones are interpolated. So all of those are interpolated. Let's select the file each time, same file. Okay, now this should take us to, if we've done it correctly, it should take us up to 11. There we go, 11. And here we're going to go 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1. So basically the boundary will have 11 points around this boundary and it will linear interpolate it between. I'm just going to click on soft boundaries as well and use the default. This is because we have U and V values available to help sort of drive the boundaries and smooth them. Okay, let's just zoom this along and just check we've got 10 and 11 there. Okay, now on to runtimes. Our runtimes will be the same as our conceptual model. We'll start in 2010, 12 o'clock. In terms of time step, we'll go for 45 seconds. And let's run this for quite a long time. So we're going to run it for 15 days. 28,000 there. Okay. Initial conditions, we'll set that as 1.5 meters. Physical parameters, we need to put in the Coriolis, 50.68. Numerical map parameters, we need to make sure we've ticked tidal flats. Save the standard results. In terms of logging time now, we'll put 20 because there's 20 in 15 minutes. If you divide that, that'll give you 45 seconds. So let's go back to build. Here I'm going to put real Solent, run title real Solent. Always make sure you save the workspace regularly. Click Run, Validate. For some reason, you might need to just click out of there, run it again, and hopefully we'll have 0 errors this time. 0 errors. I'll just check I put 12 PM. Okay, now we can run locally. Now this will take a while to run. It could take up to half an hour to run this model. Just because we've got a huge number of nodes, and unlike before when we just ran it for a few days, now we're going to run it for 15 whole days. Okay, so you can see it's processing. Like I said before, click on the refresh, and you could do down. So at the moment it's just setting up the run. Here we go. It's starting to run. So it's just creating all of the boundaries and everything, doing everything necessary. And you can see it's run 20 time steps so far. Click it again. we're up to so let's click that again. Okay, we've now run more like 80. So you can see it'll take a little while to run this one. Now while that's running, let's return to Blue Canoe and jump to stage 5. So once that's run, we can load that into Blue Canoe. And day 4 tutorials will be all about looking at the results of this particular simulation and validating it. But in day 5 tutorial, I'll show you how to compare two simulations, so a sort of baseline and a scenario run. And for the scenario run here, in your assignment, you're going to be dredging that channel, but now we're going to look at what would happen if we raised this bramble bank deeper. So if you just click on the model, the grid cells here are roughly sort of 5 meters, but what we're going to do is we're going to raise that we're actually going to raise that up to 5 meters. Okay, so what we're going to do is if you go to open your day 3, again load in bramble bank 5 meters, and this is what I've created. All I did was use the close line and just give it a value of 5 meters, so you can see the 5 meter mesh there. And what I am going to do is just create is now map the object onto that. So what I'll do is for time, normally I'd create a new grid, but for time I'm just going to click on this grid. We've already got the raw bathymetry to it. I'm just going to go map object, and now I'm going to map my bramble bank object onto it. Click no. And what you should see now is when we click on this, it should have raised the levels. So let's just bring that new mesh to a new 2D view. And you can see they're all 5 meters now. So what we can do is go File, New, Cellophane Object. Let's call this Southampton's Water Real, and I'll just put understroke BB on the end for Bramble Bank. Let's drag that mesh in there. Remember to click on it and select properties as bottom, apply, OK. And we can save this now to day 3. And I'll save it as Southampton Real understroke BB. Now you can check that it's done the right thing. What I'll do is I'll open a new Blue Canoe window. So let's just load in those 2 grids and just check that one is higher than the other. So what I'll do is load in both. And what I'll do is, rather than plotting the grid, I'm going to plot monochrome and surface. And what I'll do is I'll change the scales here. I'm just going to go from -10, intervals of 2 meters. Okay, and what I'll do is I'll bring in my other bottom for Bramble Bank. What we should be able to do is just zoom in here. Let's just turn on the color scale, show legend, and then what we'll do is we'll plot the Bramble Bank one as well. Again, make that a surface. Change the color scale. We'll go to -20, set that to 2, apply. And if we put these side by side, tile horizontally, or tile vertically would probably be better, what we can do is zoom in. So we have the simulation with Bramble Bank, and you can see it's been raised in there, whereas in this plot it was before. So yep, that's right, we can close it down. So what we'll do now is go back to Pixus. Let's check on our previous simulation. It's still running. It's got to 2,300 iterations. How many did we ask for? We asked for 28,000, so it's still got a long way to go. But what we'll do is click back on Workflow, add new workflow. Again, this is a 2D model. At some point, open a 3D template and see what it looks like. And let's name this one Real Solent BB for Bramble Bank. Set this up in exactly the same way, although this time load in your new mesh you've created. So what we'll do now is we've got a Real Solent, that one's running at the moment. Once that's finished, set up and run the Southampton with Bramble Bank. On day 4, we'll focus at looking at the results of the Solent one, and in day 5, we'll compare the two. And by then, you should have all of the tools ready to do your assignment.